Okay, so we're going to be looking at lesson 4.4, heat of vaporization. And this is what happens when, we're going through phase changes. What we talked about how when, um, a liquid goes into a gas, there's no change in temperature. It stays at 100 degrees Celsius. So we're going to calculate how much heat we need to bring about that change in state. All right, and so just a review, our three states of matter are solid, liquid, gas, and these words in the smaller font, those are our phase changes. So the states are solid, liquid, gas, and the others are phase changes. Okay, so we're going to be looking at just phase changes the next two lessons. Heat of vaporization is the heat required to vaporize 1 mole of a substance. Okay, so it's a unit. You'll find these again in your data booklets, so make sure you have your data booklets handy again. So essentially, the amount of heat we need to change the state of 1 mole of a substance. The units are kilojoules per mole. Okay. All right, so our new formula that we need to know is Q is equal to N times HVAC. Q is energy in kilojoules, and it has to be kilojoules. Okay, if it's in joules, you need to convert it to kilojoules. Small n means number of moles, and we learned that last unit. The unit of a mole is an mol. So it's basically just mole shortened. And HVAP stands for heat of vaporization. Again, you'll find it in your data booklet. You'll find it actually right next to the specific heat capacity column. All right, unfortunately, if we were to do an experiment in class where I told you to calculate the heat of vaporization of something, I can't give you a measuring instrument to measure a mole. So unfortunately, most experiments only give us the amount of a substance in mass. So we're going to have to use this formula once again. Number of moles is equal to mass divided by molar mass. So number of moles, this means mass, this means molar mass. You guys, mass can only be in grams. So when you're doing heat of vaporization experiments and they give you a mass in kilograms, you have to change it to grams. The reason is molar mass only comes in grams per mole. Okay, so when we're trying to figure out the number of moles, Okay, we need grams only. So instead of using two different formulas and two different steps, we can actually just combine this formula, okay, with our heat of vaporization formula. Does everybody have that down before I scroll down? Are we good? All right. Gavi says we're good, so I'm moving on. Okay, so we're going to substitute, instead of saying Q is equal to N times HVAP, we're going to go instead, Q is equal to mass divided by molar mass times HVAP. I don't like the way this looks. Let's just write it again. Mass divided by molar mass times HVAP. There. That looks better. This way we can plug everything, all of our units, into our calculator with one equation, and we eliminate one step this way. And of course, you know, life is not always easy for us. At times we will be asked to manipulate or move around the formula. So sometimes we need to find number of moles, and that'll be Q divided by HVAP. And sometimes we need to find what the HVAP is, and that'll be Q divided by the number of moles, or you could say mass divided by molar mass. So make sure you remember that there will be three versions of this formula. The version where we're finding Q, the version where we're finding number of moles, and the version where we're finding HVAP. So I'll go through two examples, or one if you think you've got it. Okay, so the nice thing about most of these questions is we're dealing with water. So water, we already know the molar mass too, so we don't have to think about that. But anyways, so let's write these down. Q is equal to, usually we're going to, I mean, sometimes they'll give us the number of moles, but usually we're going to need mass, molar mass, and HVAP. So the question reads, how much energy, that's what we're trying to find out, is required to vaporize 22 grams of water? Okay, so water tells us two things. We know the molar mass. It's not. It's not. So just at the very bottom of your page, why don't you just copy this one down? Okay. Yeah, sorry. This one is not in your booklet. So just somewhere in your booklet, just write this one down, or you can just watch it. Okay, so water tells us two things. Molar mass is 18.02 grams per mole. We didn't have to calculate that one, we just know it. And then we need our data booklet to find the heat of vaporization of water. So if you look for HVAP of water, you'll see that it's 40.65 kilojoules per mole. Okay, and we need to find the heat. So heat, and instead of finding the number of moles separately, we're just going to plug this into the formula, mass divided by molar mass. times HVAP. Q is equal to 22 grams divided by 18.02 grams per mole times the HVAP, which is 40.65 kilojoules per mole. All right, and then you'll just plug this into your calculator. Opening bracket, 22 divided by 18.02, closing bracket, times 40.65. And then you end up with 49.6 kilojoules, and that's rounded to 3 significant digits. Okay, would you like me to try one example where you have to find molar mass first? Let's do this one. Again, this one is not in your booklet. Okay, so you could just follow along or write it down somewhere. Again, we're going to just start with Q, N, mass, molar mass, HVAP. So this one will be a little bit trickier. This one we need to find the mass in grams. So we actually have a couple of steps that we probably have to do here. All right, we have our heat, which is 36.8 kilojoules. Okay, we don't have the HVAP and the molar mass, but we can look it up. Okay, so we're looking at methanol. So look in your data booklets. I don't know if you can see me, but in your data booklets, you will find the HVAP for methanol, and it is 35.21. Okay, and now we need to find the molar mass. Of methanol, so it's CH3OH. All right, we have 1 carbon, we have 4 hydrogens, and we have 1 oxygen. All right, we've got 1 carbon is 12.01, 4 hydrogens at 1.01, and 1 oxygen at 16.00. So our molar mass of methanol is 32.05 grams per mole. Oh. Okay. So we have a lot of information here. We have to find mass, but we can't do that. We can't find number of mass we can't find the mass this way. We're actually going to have to use this formula first. Number of moles is Q divided by HVAP. Okay, so to find the mass, we need this formula actually. Mass is equal to number of moles times molar mass. We can't even do that until we find the number of moles. So we're going to start with this formula right here. Number of moles is Q divided by H vap. Number of moles is, what's our heat again? $36.8. Divided by 35.21 kilojoules per mole. And that gives us 1.0451576 moles. Now, ultimately, we shouldn't be rounding that. Now that we know number of moles, we can go back up to this formula to find the mass. Mass is equal to number of moles times our molar mass. So our number of moles is 1.045. I'm going to leave it at that, times our molar mass, which is 32.05. Okay, and that should give us the right answer. Rounded to 3 significant digits, the mass is 33.5 grams. So you really need to work with the clues. You need to gather all your clues, gather your information. You're either going to need to start with the heat of vaporization formula, or maybe you need to use one of the molar mass formulas. But either way, you're going to need to know all of them. Okay, what I have for you is you have a whole bunch of questions. Not a whole bunch. You only have 6 questions, problems, on the next page, but not enough room to actually write the answers. So what I've done for you guys is I've typed up another page, which is the next page. Those are the exact same questions, like on the next page. So, there we go. Oh, there. So you'll have a page that looks like this. And you'll have 6 questions on it. Oh, really? Come on. Okay, well, in your booklet, I have a spot for you to answer these questions. So, yeah, just work on them. Okay, and that is actually kind of all I need to do with you guys today. So work on those. Yeah, and then you're done for today. So I'll leave